I got 4 examples to show you. And hopefully it'll all make sense, okay? So first of all, a polynomial inequality is an inequality, so it's going to have a greater than, less than, or greater than or equal to, or less than or equal to. And it's going to contain a polynomial. What you're used to doing is back in Algebra 1 would be just linear. You just had an x, and then you graph it on a number line. Do you remember this? Okay, we're still going to be using a number line. But we are now involving an x squared or an x cubed or an x to the 4th. So there are several answers to this polynomial, and they're within an interval. Interval meaning like they could be between 3 and 5. They could be between 5 and infinity. So we have to find out these boundary points. And we have to find out the correct solution. So let me give you, I'll put it over here on the side, the steps. And if you can follow these steps, hopefully everything will fall into place. Step number 1, you never ever want to work with a polynomial unless it's set equal to 0. So every time on tonight's homework, please make sure everything is set equal to 0. And by the way, what I mean by set equal to 0, I mean everything is moved to one side, 0 is on the other side. So not necessarily set equal, but the one side has a 0 on it, okay? Step number 2, we are going to find our zeros, which are our boundary points. And when I say zeros, it's just like we were finding our zeros, what the whole last couple of sections have been about. Find those values that make it 0. Okay. After that, we're going to perform what's called a Sine Test. This will probably be new for you, but we are going to perform a Sine Test. Step number 4, you shade what's true. I'll explain that in a minute. Shade what is true. You don't shade what's false. That's silly. And then last and final, step number 5, write it in interval notation. Okay, set equal to 0. Find those zeros, find those boundary points. We're going to go on a number line and perform what's called a Sine Test. Once we do that Sine Test, we shade what's true and write in interval notation. Seems very easy, but obviously there's some work here. Okay, so let's go over here and start this one. So set this equal to 0. This would be x squared minus 6x minus 27 is greater than 0. Do you all agree to that? Okay, now, in your little mathematical heart, you should want to do something, this little trinomial. What do you want to do to him? Let's factor him, because what we're doing is right now is we're finding those zeros. Okay, so x, 2 numbers multiplied, negative 27, add to negative 6. And 3? Yeah. Okay, now, you're going to stop right there, and you're going to put a box around this factored form thing, and I'm going to show you why in a minute, because that's what actually we perform the Sine Test on. We do the Sine Test on this. We actually don't do it to the original. Okay? These numbers right here are your zeros. So you are going to go to a number line, okay, and you're going to plot those boundary points. Those boundary points are, again, 9 and negative 3. Agreed? So you're going to go to negative 3 right here, and then 9 right here. Don't put open, don't put closed, don't put any, remember, we're not in that anymore. We're in PreCalc. We do brackets. We do parentheses. We don't do open, closed. So now you're going to do and perform what's called the Sine Test. So a Sine Test, what you've just done is you have divided your number line into 3 areas. All the numbers that are below negative 3, yes. All the numbers that are between 3 and 9. And then all the numbers that are after 9. So we need to figure out where the x's can be true to this statement. What x's will make this statement true? There's several of them. Again, we're talking about inequalities here, so there could be tons of x's. 10 could work, 11 could work, negative 20 could work. We don't know. So how do we figure this out? Well, you do the Sine Test. So the Sine Test says, so I kind of do this. I kind of separate it into my zones here, to the zone 1 here. You are going to pick an x that's in this zone right here. Pick a number that comes before negative 3. It doesn't matter what you want. Pick any number, I don't care. Pick a number. -4 sounds good to me. So we're going to pick x to be -4. We are also going to pick a number in between -3 and 9. Pick an easy number that comes in between -3 and 9.
0.
Good job, John. 1. Oh, 0. So we're going to pick x to be 0. So that's in our second zone. And pick a number in our third zone. Anything above 9, what would be easy? 10. Okay? What you do with these numbers is you perform a sign test. You plug them into this factored form, and you only look at the sign. You don't have to really worry about the number. Now, there are people in here that are like, can I just get the number? I just feel happier when I get the number. Go ahead, get the number. But really, you should just be worrying about signs. So here's what I mean by signs. What's a negative times a negative? And aren't all positive numbers greater than 0? Right? Okay. What's a negative times another negative? Negative. Are negatives greater than 0? No. So what I do is, watch what I do, and then hopefully you'll pick up on. I take -4, and I plug it right in here for x. -4 minus 9 is still negative. Would you agree? -4 minus 9. Then I put -4 in here. -4 plus 3 is what? Negative or positive? Negative. Don't tell me what the number is. Just tell me what the sign is. Perform a sign test. What is a negative times a negative? Is a positive number greater than 0? Is that true or false? That's true. So right here is true, and that's where you would shade. This is true. Let me do that again. Let's do it with 0, okay? So I'm going to plug 0 into this factored form. If I put 0 minus 9, wouldn't you agree that still makes it negative right here? 0 plus 3, though, is what? Positive. What's a negative times a positive? It's a negative. Is a negative greater than 0? That's false. So I do not shade here. No shade right here. And you can put a little X there. I don't care. But I'm just saying don't shade there. All right, now I put 10 in. 10 minus 9, that's positive. 10 plus 3, that's positive. What's a positive times a positive?
Positive.
Is that greater than 0?
Yes.
So you would shade right here. Okay? Now, we just actually solved the problem. We just have to write it in interval notation now. If you are greater than, what kind of notation would be here in terms of parentheses or brackets? Here or here. Do you think it would be a bracket or would it be a parenthesis? Why parenthesis and not a bracket? Can't equal 0, right? If there was an equal sign here, you'd put a bracket. All right, so can you write this in correct interval notation for me? What would this be? From where to where? From -infinity to -3, you would actually get a true statement up here. That would work in our polynomial inequality. United with, where's the other zone? 9 to infinity. This is the solution. These are all the values of x that work in this polynomial. Those are all the values of x that work in there. How did you feel? Yeah. Let's go to example 2. We got 4 more to go. 4. Yeah. They just get increasingly funner. X cubed minus x squared minus 4x plus 4 is greater than or equal to 0. Now again, children, I have taught you now for several lessons how to find zeros. Find zeros of polynomials. What could you do right now?
Fantastic Four.
You could do Fantastic Four, which we're going to do, but really, what's the other thing you could do if you're allowed this on your... Go to your calculator, go to what? Table, find the zeros, and then you have half the battle there, okay? But we're going to do Fantastic Four, John, because you said so, and I'm proud of you for remembering that, okay? So let's factor this and let's factor this. What can you factor out of that? X squared, and you're left with x minus 1. What can you factor out of a -4x plus 4? -4, and you're left with positive x minus 1. Ah! Regroup this would be x minus 1 times x squared minus 4. And what does that factor into? x minus 2 and x plus 2 greater than or equal to 0, okay? Again, could you have gotten this from your calculator? You sure could have. You could have gone to the table, but you would have to write it in a factored form. Are you with me? Box the factored form, because that's where we perform the sign test. We perform the sign test on the factors, okay? So now I draw my number line. On my number line, I'm going to put in order. This is where a lot of students make the mistake. What's your smallest zero? Let's write them out here. 1, 2, and negative 2. Negative 2. Then comes what?
2. Or 1.
1. Then comes 2. Okay, what I've just done is now divided this into 1, 2, 3, 4 zones that you have to test. 4. You have to test a point here, in here, in here, and in here. You have to, because there's multiple answers to these. So let's pick some values. So we can all do this together. Pick a number that comes before negative 2. Negative 4. Okay, she's going crazy. Pick a number that comes between negative 2 and 1.
Yeah.
That's the best one to pick. Pick a number that comes between 1 and 2. 1.5. And pick a number that comes after 2, 3. Okay? So again, here's what I do. I'm only worried about the sign. And I write the sign of each factor down. So I'm going to plug negative 4 everywhere I see an x into this. What's a negative 4 minus 1? What's the sign? Is it positive or negative? Negative. What's negative 4 minus 2? Positive or negative? What's negative 4 plus 2? Negative. If I put negative, 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 is that greater than or equal to 0? Is that a true statement? Yes or no? No, because 3 negatives make it negative. That's false. Don't shade here. Okay? Don't shade here. Let's do it with 0. Plug 0 in. 0 minus 1, negative. 0 minus 2, 0 plus 2. Is that greater than or equal to 0? Oh, so we are going to shade here. All right, you do 1.5 and 3. I'll freeze it so you don't see what I'm doing. Okay, I ended up with a positive, negative, positive, which is false. Would you agree? When you plug in the 1.5?
Yeah.
So you're not going to shade here. But this last one, when you plug in a 3, you get a positive, positive, and a positive. Multiplied each other would be greater than 0. So that's true, so you're going to shade here. Okay, now, since it's greater than or equal to, these zeros get what? What symbols? Brackets. They're not open. Okay. So someone help me out here. How are you going to write the notation for where the x's are for this one? Between where? Negative 2 and 1, united with bracket 2 to infinity with a parenthesis. That's where all your zeros, that's where all your x value solutions are located for that polynomial inequality. So far, so good? Okay, ready for the good one now? Yeah, let's do this one. Example 3, and then example 4, and we're done. Solve. Oh, I love this one.
I don't like anything with this word solving. That means
So again, you want this to be equal to 0. I already did it for you. Such a kind person. The other thing is you have a fraction here. When we're talking about where are our zeros located, our zeros are anything on the top and anything on the bottom that would make it a 0. Okay? So zeros, my zeros would be at x equals 2 and 1. Would you agree? And then what about the bottom? 3 and 4. Okay, and yes, has multiplicity. So zeros are on the top and the bottom. But here's my problem. Even though this is less than or equal to, not every one of these are going to be bracketed. Do you know why? Can you think of why? What are we not allowed to have in a denominator? A 0, but Mrs. Sutter, you just made me put zeros here. Yes, but I don't want them to equal these. Those bottom numbers, I do not want them to be equal because that's not allowed in math. So these bottom numbers have to have parentheses, always. The bottom zeros always, always, always get parentheses. Are you with me? But the top ones are allowed to get brackets. In this case, they're allowed to get brackets because I have an equal sign. If this was just less than, or if this was just greater than, then everything would have, all the boundary points would have parentheses. Okay, so you might want to write that down. If it was just less than, or if it was greater than, then all boundary points would be open. We'll say that. If that right there was just less than or just greater than, then all those boundary points are open. But because it's a greater than or equal to, just the tops get bracketed, the bottoms get open. Okay, so that's the first thing I need to talk to you about. Some things just to remember. Now we're going to make our little number line. And I'm going to go again in order on my number line. So great thing is I have 1, 2, 3, and 4, so that's not too bad. 1, 2, 3, 4. But do you see how many zones I have to test right now? 5 zones. Okay? So let me again show you how to test these zones. You still have to pick numbers, but it's kind of it's just slightly different with a fraction. So you pick a number in each one of these zones. So pick a number that comes before 1, make it easy. 0. Pick a number between 1 and 2. 1.5. Between 2 and 3. 2.5. Between 3 and 4, 3.5. Between or after 4, we'll pick 5. Okay? So I'm going to do this first one with you and then see if you can finish out the rest here. So I'm going to put 0 in here, 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 and here. Now, here's the beauty about this one that's being squared. No matter what you do, no matter what this becomes, what does this last one always have as its sign? Why? Because you're squaring it. Okay, so I'm going to put 0 here, and let me kind of zoom out here so you can see what I'm doing. This is what I do. If I put 0 here, I would have a negative. If I put 0 here, I would have a negative. Divided by, if I put 0 here, I have a negative. But this last one, we just talked about it, is always, because it's squared, positive. Now, in mathematics, whether you're multiplying by 3 negatives or dividing with 3 negatives, 3 negatives is odd. An all odd amount of negatives is always what? Always negative. An odd amount of negatives is always negative. An even amount of negatives is positive. So an odd amount of negatives means it's negative. Is a negative number less than 0? Is that true or false? That's true. So I am going to shade right here. Okay? You do that now with 1.5. Do the same thing. Positive. Do you agree? 2 negatives make a positive. Are positive numbers less than 0? That's false. Don't shade here. Now, Mrs. Setta, is that always going to happen? Is it going to be shade, don't shade, shade, don't shade? Sometimes yes, but sometimes no. I can't tell you all the time that one works all the time. So try 2.5, try 3.5, and try 5 right now. Plug those values in and see what. When I did the 3.5, though, it was false, which means that what else is false? The rest of it. Wouldn't 5 also be false if everything else after that is false? So, okay, so now how am I going to write this? Well, at 2 and 1, you need to have brackets. So you need to have a bracket here and a bracket here. At 3 and 4 are parentheses. Because 4 is a parentheses and nothing happened after 4, I really don't need to put a parenthesis there. It just wouldn't be a part of my solution. So my final answer would be that your x values can be less than, from negative infinity to 1, united with 2 to 3. Interesting, right? I'm going to do one like your homework tonight. Actually, I think it's from your homework. Is it from your homework? How nice of me. If it is, if it's not, sorry. Last example. Find the domain. This is actually how it's used. All right, last one. We've talked about this before. Underneath a square root symbol, what are you not allowed to be? Negative. You could be 0. You could take the square root of 0. So you are allowed to equal 0, but you have to be greater than 0. Oh, so what's underneath has to be greater than or equal to 0. Interesting. That's an inequality. That's a polynomial inequality. Find your zeros. Plot them on a number line and test the zones. Give you a minute to do that. Hopefully you got 3 and 4, right? Okay. So you're going to test the zones. Pick a number that comes before 3. Pick a number in between. And pick a number after 4. If I plug a 2 in, I get negative, negative, which makes it positive, which is greater than 0. You do shade this. 3.5, if I plug that in, I would get positive, negative, which is not greater than 0. False. Pick 5, I get positive, positive, which is greater than 0. Agreed? Okay, and then is it bracket or parenthesis? Bracket. So your domain for this answer would be from negative infinity to 3, bracket, united with bracket 4 to infinity. How are you feeling about this? Have you ever done this sign test before? Is this brand new for you all? Yeah, I had a feeling it was. All right, so here's what you got to do. So you got a worksheet tonight and then a few of the book problems. You could probably do the book problems, like bang them out real quick right now.